Hi everyone and welcome to our discussion for Book 1, Proposition 13 of Euclid's Elements. Proposition 13: if a straight line stands on a straight line, then it makes either two right angles or angles whose sum equals two right angles. As a personal assessment, through this proposition, Euclid started to introduce the adding of angle magnitudes. Hence, through this proposition, we are showing the parameter that the sum of 2, 3, and of all angles standing in one line is equal to two right angles. So again, we have two situations, two right angles in the straight line, and the sum of all angles standing in a straight line is a sum of two right angles. So here are our components for the figure and the proof. First one is the definition of right angles and perpendicular lines. So that's at definition 10. Okay, this one. And we also have the drawing of right angles using a point within the starting line. So that's proposition 11. So line DC and point B along line DC. That's proposition 11. And we'll be making use of a lot of common notions. The common notion that the whole is greater than its parts, and for the algebra part of the proof. So before, at the time of Euclid, we don't have the mathematical algebraic expressions of equality and inequality and the adding and the subtracting of elements or components. Then we are citing common notions to justify that it's okay to add, it's okay to subtract, and that the whole is greater than its parts. Okay, so let's now proceed to the detailed steps of the proof. So for the situation 1, so let's simulate proposition 11. So we have a segment AB, and then we'll have a point along AB. Okay, and such point will produce a line that will be perpendicular to line AB, and that will be the common side of two right angles. Okay, so again, that has been shown and proven at proposition 11. So let's now construct the figure of proposition 13 as shown here and use this for the proving part of situation number 2. So we'll start with a line AB which is non-perpendicular to line DC. Okay. And again, since this is non-perpendicular to line DC, then we have two non-right angles. We have angles which are not right angles. Okay, so we need to have a situation wherein we have two right angles because we're comparing it to two right angles, right? So in order to do that, we'll have a point E which will not be within line DC. Okay, so point E. Okay, and then that would be the line now that would be perpendicular to line DC. Okay, and observe further that DBA and ABC here are not two right angles. Okay, and having point E, okay, we have the perpendicular line EB, and we now have the right angle DBE and right angle EBC. Okay, now let's consider this side, the side of angle EBC. We can see in the figure that the angle EBC has two subangles. It has the subangle EBA and the subangle ABC. So we can now say that the right angle EBC is equal to EBA plus ABC. So that's why we have this equation here. And then we will now add DBE to both sides of the equation. So EBC plus DBE will be DBE plus EBC here. This DBE is another right angle. So this side of the equation would be like the sum of two right angles. So we have two right angles here. Now, at this side of the equation, we will also add DBE. So DBE plus EBA plus ABC. So we have this. And since they are equal, from this statement and adding DBE to both sides, these are equal, then this expression gives us the statement that the sum of these angles is equal to two right angles, right? Okay, so furthermore, considering the construct, we have DBA here, and it has also two subangles, DBE and EBA. So we can then say that EBA is equal to DBE plus EBA. So we have this equation. Then let's add ABC to both sides of the equation. Okay, so ABC plus DBA, we have this, DBA plus ABC. And ABC to be added to the side of the equation, then we have DBE plus EBA plus ABC in here. Okay, and this expression is somehow been mentioned already here and described as having a sum that is equal to two right angles. So we'll just have the same description. So this sum equal to two right angles is equal to DBA plus ABC. So then we can say that DBA plus ABC also means a sum which is equal to two right angles. So there we have just proven, or we just have shown, okay, the truth and the validity of situation 2, that the sums or the sum of all the angles along one straight line is equal to two right angles. So thank you everyone for listening and stay safe.